Hey guys, it's Coach Zane here, and this is going to be the final video in the FTC tutorials playlist. And in this video, we're just going to be wrapping up our FTC Drivetrain. So in the past two videos, what we did was we created our ultraplanetary motors and we stuck them to a drive rail. We then duplicated that drive rail, so we have two drive rails. And in this last video, we're going to be combining those two drive rails together. So without further ado, let's go to the screen. So this is exactly where we've left off last video. So we've created our two drive rails. Now if we go back to the documentation, you'll see that our drive rail, I've got the final assembly kind of kit open. The essence of this is we're going to now take our two motors, our two drive rails, and we're going to face them opposite each other. And then we're going to connect them in two ways. We're going to connect them with a C channel, and then we're going to further support them with two extrusions at the top and at the bottom. And then we're just going to add the wheels on, and that's pretty much it. So without further ado, let's go back here. The first thing we'll do is we'll just kind of rotate this around, just so it's kind of easier for us to manipulate. Anything that kind of resembles the way we're going to mate them in the future is kind of good enough for us. And there we go. So as you can see, I've kind of moved things around. That took me a little while, but now we can kind of picture how our drive rail is going to be. We're going to have a C channel kind of along here, and then we're going to have two extrusions down at the back. So the first thing we need is we need to now import the correct length of C channel. So I'll go to my documentation, and as you can see, the C channel we're going to need, it has it listed right at the top. So we're going to need 248mm C channel. So that rev number is 1767. Go to the documentation, insert component, SOLIDWORKS parts, go through the process, and 411767, which is just this one here. So we'll let it load. We'll just rotate this slightly to kind of get it in somewhat of a better view. There's not too much we can do. That kind of looks okay, and I'll just rotate this around inside. So I'll grab that piece and I'll just rotate it like so. So we'll just flip this around, keep flipping it around. We'll get the other side just there, and we'll keep flipping it like so. So now we've got our C channel, and it's resembling kind of how we need to connect it. The connection to the C channel, it's going to be a little bit more difficult than other connections, but we'll just follow logic for now, right? So the first thing we know, if we go back to our documentation, this C channel, as we scroll here, it needs to be coincident mated to the two drive rails. As you can see, there are brackets here. Now, in SOLIDWORKS, these brackets, they don't really matter. The reason being is because brackets are just like screws. They help connect things, and we don't connect things with brackets or screws in SOLIDWORKS or in CAD. We connect them with their faces by mating things. So you don't really need to worry about these brackets. You can just think about it logically. You can see that the edge of the C has to hit the C channel of the drive rail, which means we just need to coincident mate it on both sides and see what happens. So we'll do that first as logic dictates. So we'll grab the face, which is just there, press shift, grab the face of the C channel, let go, and we'll coincident mate it there. So that's looking pretty good. We'll do the same thing to the other side. Before I do the same thing to the other side, something I want to note is that this C channel here, we want this to be the fixed object in our system, right? So if we fix this, that's going to be the thing that the rest of the build is going to be centered around. Whereas if that wasn't fixed, then the whole object will just fly around our whole drive assembly. So we want one object within our CAD file to be fixed, so then we can now connect our drive rails to that fixed object. And because it's kind of the center of your object should really be the fixed object, and this C channel is a good kind of center point. So now that that's fixed, when I mate my other C channel, you'll see that the other C channel has to move toward the middle C channel. So I'll press shift, let go, and now I'll coincident mate them. So now they also share kind of the same plane. So we still have a few more problems. The first thing is that this C channel isn't really flush with the top. So as always, if things aren't really flush or they're at an angle, we'll try to parallel make them. So let's go ahead and do that. So I'll just take one side here, just the actual face, press shift, let go of shift, and let's try parallel mating those. So if we look around, we can see that one side is kind of parallel. We just have to do the same thing to the other side because this one is now still kind of wonky. So we'll just copy the exact same mate, but we'll do it to the other face. So shift, make sure we get the right face. And now we'll try parallel mating this way. So that did work. We don't have any errors. But the only problem is that this C channel, if we look at it, it's kind of in the wrong position, if that makes sense. So this drive rail can still move kind of this way and that way. It's still kind of coincident mated, but if I just turn it around, it can still move up and down basically. We now need to find another mate to level or to get the correct positioning. So now I'm just going to try to coincident mate the top. As you can see, this face here, it's like it's level with this, kind of like they're parallel to each other. For example, my two hands right now, they're parallel, and even if there's a height difference, my two hands still are parallel. It's the same thing with this C channel face here and this C channel face there. They're at the same kind of like parallel alignment, but they're not at the same level. So to bring it up, let's try to coincident mate those two faces. So we'll press shift, let go, and now let's see what happens if I coincident mate them. So perfect. As you can see, now that C channel is looking pretty good. It's level with the actual drive rail, and we'll do the same thing to the other side to bring that to the correct level. Shift, let go of shift, and we should coincident mate those there. Perfect. So now everything is looking pretty good. There is still one final way this can move, and that's forward and back. So this forward and back movement, if you think about the bracket, right? So I'll go back to my documentation. Once again, both of these can move forward and back. So this is a bit of a problem. You can now kind of try explore, see what mates you can find to kind of solidify that forward and back. But the problem is our C channel, it has no holes kind of on this edge here. It's just a C. If you can't really see the edge because it's perfectly mated. It's just that one there. As you can see, the highlighted part, there are no holes there. It's just a complete C. And it's kind of the same thing for the top of the drive rail, or for the side. There are holes here, but no holes align with the C channel, which means we can't coincident mate them in any way. So if we go back to our documentation, these are actually going to be brackets, and these brackets, if you're familiar with the Rev build system, these brackets can actually move back and forth within the system, which means there's no real way to mate them within SOLIDWORKS except for fixing the drive rail. So I'll show you what that means in SOLIDWORKS. As you can see, this drive rail here and this drive rail here, because they can move forward and back and there's no way to mate that forward and back, your only option is to fix those actual drive rails. So what we can do is a neat trick, right? As you can see, if I move this forward and back, and if I move this forward and back, these may not be perfectly like flush with each other from the front. So let's try and coincident mate the face of this and the face of this. So let's click them again. I forgot to press shift, click them, and let's see what happens when we try coincident mate them. So now that they're coincident mated, they should both kind of move together. As you can see, now the whole system is level, and so the last thing we need to do is just fix the positioning of those drive rails, and only one of them, right? Because as soon as we fix this one, the other one has to stay in line with it. So once we fix the drive rail on the left or on the right, the corresponding one on the other side will become fixed too. So to give ourselves enough space, we'll kind of maximize the space at the front. So we'll just, we don't want to kind of, we have a bracket here and our C channel there. So we don't want to make them touching each other, but at the same time, we do want to maximize the space at the front. We also don't want to leave too much space at the back, right? Because we have to put two extrusions there. So I think this is kind of like a good distance there. So once you're happy with that, it's also like if there's a problem later on, we can just kind of float this object and then we should be good. So let's fix this object. We'll just hit kind of a face and then we'll press fix. So now this whole object is fixed and our drive rail is looking really good. So now you can see we can't really move this around, but that's not a big deal because our drivetrain has to be fixed, right? We're not going to move around this drivetrain when we're building on it. We want it to be a platform that we can build on. And like any platform or foundation, it's good to have it fixed within the ground. So let's go back to our documentation and see what we have to do next. So we'll just open it. And we're doing things kind of slightly out of order, but it doesn't really matter. So the last thing we have to do is put 2 extrusions kind of on the back. This is just for further stabilization. As you can see, we kind of have like a H-frame without those 2 extrusions, so that can kind of bend inwards and outwards. If we have kind of like more support at the back, that will support our whole drive system from the back and from the middle, and it leaves some good intake space at the front. So we'll go ahead and we'll do that. So the extrusion we're going to need, it's a 420 millimeter extrusion. So we'll go back here and we'll find it up top. So it's going to be row 411432. We'll enter our component, all files, 411432. It's just this one here. Open that, let it load. Once again, we can see that our object is flying around, so we'll try rotate it. Now, instead of trial and error, there is a neat way you can kind of see where your object wants to go. So I'll move this around, but I'm moving it in a certain way. So if I just move it around a little bit more. Alright, now what I want you guys to focus on is this X, Y, and Z. I can't zoom in on it, but the Z is blue, the X looks like it's red, and the Y is green. If I move it, if I press X, it's going to move. It's going to rotate around the red line. So you can imagine if there's a red line going through the extrusion, once I press X, it's going to rotate all the way around the red line. Similar for Y. So because Y is kind of along the direction of the extrusion, if I press Y, nothing much is going to happen, right? Because it's just rotating the square, turning it this way, which means the square has the same orientation, or the cross section stays the same. So Y isn't going to do much, but Z, the blue Z axis, it'll rotate it this way. So we'll press Z, and we'll see that it's actually rotating kind of around like so. So if you're ever like, if you want to do things legitimately instead of just trial and error, you can. Personally, I'm more of like a trial and error person, engineering, right? So I'm not really too fussed about the actual theory. I just want to get the practical sense done. So I can kind of move this around and manipulate it to get it to the exact direction I want. So that kind of looks pretty decent. We'll drop it in there. Make sure we have it at the correct position. Yep. We'll rotate it slightly just to get a better fixed positioning of it. So we'll rotate it about like so. Get it into the frame. Rotate it again. Oh, there's a position there that may help us. There it is. And yeah, that is pretty good. So if you're curious how these actually connect, they connect through brackets. So if we go back here, you have to create these preloaded brackets, and then these brackets, you just slide 2 extrusions onto the brackets. And then the end goal is that you're just going to have 2 extrusions kind of at the back. So we'll go ahead and we'll try to mate these brackets. So the first thing you can kind of suss out is that the face of the extrusion, it needs to be coincident mated to this part here. So it just needs to be kind of along that plane. So what we'll do is we'll hit one of the faces, and we'll also hit this face here, press shift, and we'll coincident mate those. So now this thing, it's along the same line. We'll now coincident mate it again, but to get the level, we'll coincident mate it like so. So we'll coincident mate that, press it, do that again, let shift go, and we'll coincident mate it. So now it's kind of got that vibe there. And can this thing still move around? Yes, it can. As you can see, it's pretty good in terms of like the lining up. It's perfectly 90 degrees, but this whole object, it can still move around. And just like last time, as you can see, these brackets, the extrusion can slide in and out, which means there's no real way to make them with screws in SOLIDWORKS. Your only option is to fix this position. So I'm not going to fix it just yet. The reason being is I want to get another extrusion and do the same thing for the bottom. So I'll press Control C, Control V. And now what I'll do is I'll just mate this extrusion the exact same way I made it the top one, except it's going to be at the bottom. So I'll coincident mate it first. Oops, I have to redo that. I'll coincident mate it first there. So I'll grab one face and I'll grab another face. Anywhere along this face will work because that's all lined up with each other. So once I coincident that and that, I will now coincident the bottom and the bottom of the drive rail. The reason why I do this is to get the level, so it'll fly up to the correct level. Yep, there we go. And now once again we have that same problem where this thing can move in now. So because we want these to be parallel to each other, the top and the bottom one, we'll just coincident the faces. So we'll coincident this and we'll coincident that, and they should become level. Perfect. So coincident mating, in my first video about mating, I said it slaps things together. It doesn't necessarily slap two objects face to face. What it will do, it'll kind of make them within the same kind of plane. So if I have my two hands like so, if I want to coincident mate the top of my face here and this face here, coincident mating them brings them in line. It's not parallel mating, that's slightly different. But if you're new to SOLIDWORKS and this mating, it can get quite confusing. Like I just coincident mated as opposed to parallel mating. And you may be like, well, why'd you do that? The best way to learn is to try. So try parallel mating, see if there's an error that comes up, and then just cancel it, and then retry it and retry it. Within SOLIDWORKS, you can always go back and forth. And it's quite quick, right? Control Z, Control V. That type of thing is really helpful. So now that I've got my object here, I can kind of just eyeball it to see where I want to line this up to. If you want to, you can use the distance tool. If I go to evaluate, you can see the measure tool. You can just measure things exactly how you want them. For example, if I click measure, I can measure what the distance is from this point to this point, and then that point to that point, and then just kind of move it around to make them equal. To be honest, I'm quite happy to just eyeball it because that's kind of what we do with our build, right? We don't take the measuring tape out and figure out the same distance on both sides. We just look at it and we say, you know what, that's fairly equal. This isn't really going to impact the build later on. So we can just eyeball it, and that looks okay. So now I'll just fix one of these, and the whole thing is now fixed, right? Once again, because this part was fixed, so I didn't fix this actually. I floated it, but then I forgot to fix it. So we'll go back and we'll fix this. So now that because the middle is fixed, and these are mated to the middle C channel correctly, that is going to be fixed too. And now that this is mated to that, everything is now going to be fixed. So by having one fixed object and mating things to that fixed object, you have a platform to now build on. So this is really good. We're almost done. The last thing we need to do is just place the wheels on. So this is where I'm going to change things just a little bit. So if we go back to our documentation, we can see we completed up to this step, and the last thing we need to do is put spaces on and then connect the wheels. So just like the previous video, I'm not going to spend time on spaces. Once again, if you're in a team competition environment, do everything exactly. For the purpose of this video and not taking it too long, I'm not going to bother with the spaces, but make sure you do. Finally, we need to now place these wheels on. Now these are Rev's mechanism wheels, and they're really good. There's nothing wrong with them. But for our team, we have a different set of mechanism wheels. We use the AndyMark HD mechanism wheels. Now the reason for this is just because at that time when we bought them, we felt like this would be a much better option for us. So you can go ahead and use the Rev wheels or buy them if you want. I've seen really good teams use the Rev wheels, the mechanism wheels, and they're great. Another great option for mechanism wheels are the Go Builder Yellow Jacket wheels. I'm not sure if they're called Yellow Jacket, but they're the yellow ones. But when we looked at them, they were actually out of stock. So it just depends what's available to you, and go ahead, research what you want to do on your own. There are a lot of good sites out there, forum sites like Reddit, Chief Delphi, all of that, where you can get some good tips on mechanism wheels. Because these are the mechanism wheels we'll use, I'm now going to use these wheels instead of Rev wheels. So this is the first time we're using a non-Rev product, but just like I mentioned in the first video, this is an AndyMark website, but we have all the CAD files here the same way. So we'll just download a wheel. Let's see what happens. So that's to download. That was the left wheel, and we'll download the right wheel. Perfect. So these are now downloaded in my downloads. So when I go to import them, you'll see it's going to be slightly different. So if I go to assembly, insert component, I'll have to now go to downloads and all files. And now we can see we have our two wheels here. So I'll start off with my right wheel and I'll import that. Ideally, we'll just copy paste the right wheel to get a second one. So what I'll do is I'll show you how to make one wheel, and then I'll just cut to all four wheels connected. because mating one wheel is quite easy. Mating the second wheel and the third wheel and the fourth wheel are exactly the same. So I'll drop this down here and we'll see what we have. So I'll rotate our wheel around. It's quite a nice wheel actually. One of the reasons why we use this wheel is essentially because there's a lot of rigidity to this wheel. So there are a lot of mechanism wheels out there that simply aren't as good. So once we import this wheel, you can see there's a problem, right? This has like a 8mm bore, which means it's just like a cylinder insert, and this is a hexagonal insert. So in reality, if we were to connect this wheel on, the wheel just wouldn't have any connection to the hex shaft, because the spacing for the inside is much larger than the hex shaft. So what we need is what we call an adapter. So we'll go back to our SOLIDWORKS, sorry, we'll go back to our documentation, and the adapter, actually it's up top here, so it's just this piece here, our universal hex adapter. So to import our adapter, we're going to get the 411216. So we'll go back here, insert component, there it is. Let it load, and as we can see, we have a nice little adapter here. We'll zoom in onto the wheel just to get a good view. So actually you don't really need to rotate it manually because we have nice circles here. So the first thing we'll do is we'll concentric mate that circle. So I have to get the whole circle, not the actual face. So the semicircle, I'll grab that and I'll concentric mate it, shift to this circle here, concentric mate them, perfect. So now this whole thing is nicely concentric mated. We just have to make this flush. Another thing you can notice is that this actually isn't the... So now that that's concentric mated, we now just have to coincident mate them. So we'll press this and we will slide it onto the face. So shift, let go, and we'll now coincident mate them. So now the difference is we now have a wheel which has the correct 5mm hex shaft fitting. So now we can go ahead and we can coincident mate the same way we coincident mated last time. So we'll go ahead and we'll take one side and we'll line it up with this side here. Shift, coincident mate those. So once again, if you forget, so this time we have to be very careful about what we choose. So we'll go back up to history and we'll see what we get. So we'll coincident mate those one. So we'll just coincident mate the top now. So I'll coincident mate this, and oops, that view, I just lost it. Let's go back here. And this one, shift, and let me coincident mate those. So now this whole thing should be nicely in. Yep, it can just move in and out. Last thing we'll do is we'll just press this and we'll make this level with the C channel. Shift, let go, and we'll coincident mate those. So now our wheel is perfectly on our drivetrain. So I'm not going to show you all four because it's quite simple. All I'm going to do is do the exact same process for the rest of the wheels. Okay, so I've cut the video, I've done all four wheels, and I've come back. So as you can see, we have all four wheels on. This was the first one that we put on, and then I just duplicated it for the rest. Now, as you can see, the wheels are slightly different. That's why we had a left wheel and a right wheel. So if we go back to where we got our wheels from, AndyMark, we see that we have a left step and a right step file. Step file just means CAD file. So when we go back, our left wheel, it doesn't necessarily mean like it has to be on the left side. All it means is that there needs to be an X pattern. So as you can see, if I see this line here, and then this line here, this forms like an X going this way, and similarly, this forms an X going that way. So the left kind of has to be pointing toward the left, and the right will be pointing toward the right, and then we just have to correspond that diagonally so that the right wheel at the top left is the same as the wheel on the bottom right. So that's seen here. Here we go, top left and bottom right, we have the same wheels. Similarly, the other set, top left and top right, sorry, and bottom left. So if you ever forget this, you can go anywhere on YouTube or online and you can see. Or Rev have a very nice summary of how to place the wheels. So as you can see, you have the left and the right, and they make an X pattern going that way. So that was the last thing we had to do. As you can see, our drivetrain is complete. So once again, congratulations. This is the final video. So this is the last kind of major thing you need to do. Now I'm just going to give you some tips and tricks, kind of like what you need to do to get around maybe when you're having some trouble. So the first thing you need to know is that this whole thing, it's a large assembly, which means we have more than like 500 pieces. For example, these wheels, they probably have 100 pieces just within them. As you can see, that was within a file. So if I go back, I can close this, and the whole wheel is within this whole file here. So if I press this file, now the whole wheel is selected, and I can get the drop down, and you can see all of these pieces are within here, and all of these pieces have little pieces within them as well. So as you can see, there's a lot going on, and that's just one wheel. So you can duplicate that 4 times, plus everything that's going on within the drivetrain, which means we have a large assembly. All that means is you need to be careful when you're adding things on. Like, you don't want to be breaking your assembly too much. You don't want to be making too many mistakes when you're mating. If you see a mistake, if you want to make 2 different things together and it says it won't go, just cancel it, find your mistake, and go again. That's the first thing. The second thing is, I'll close this now. If you ever want to go and you want to fix a mistake, for example, let's just say you've done this and you want to now put spaces in here for whatever reason. As you can see, I can't really put spaces because I have this C channel blocking it. So quite simply, all you can do is you can press the object, let it load this sidebar. So I didn't press anything else. The sidebar just is automatic pop up, and I can hide the component. That means the component is now gone and I can get the side perfectly nicely. That doesn't mean it's not there. All it means is if I go back to here, go back to your left-hand tab, once again, very important, close this, you'll see there's one object that is slightly different, and it's this one here. So this object here, it comes up shaded when you press it, but it's not there yet. So because it's white just there, that means that it's not showing. So all you need to do, right-click and show the component, and now it's there again. And you can do this for any component you want, right? So if you ever need to get into space, just click the object. For example, I'll do the same thing with this hex shaft now. Click the object, hide the component, and now it's gone. And as you can see, it was this component here because it's white, and I'll just show it again. So that's another tip that you can use. It's very handy because you may make mistakes and you don't want to, delete all of your components, because when you delete like a part, you made that part 3 different ways. That's a lot of work you've put into that single component. So by deleting it, you reduce all of your work and you have to redo it. Instead, just hide the component, access whatever parts you need, and then show the component. And that way you can fix up your mistakes. And the last thing I want to mention is that this is just a simple drivetrain. So as you can see, we don't have any wiring going on here. You can put wiring in CAD. We don't have a control hub or expansion hub. We don't have a lot of like the mechanisms, the intakes. This is just your base. So using this, you can now build on top of this, build any of the designs you want to make that can complete the mechanisms and the challenge of the game. But apart from those 3 tips, that's pretty much it. So this was the last video in our series of SOLIDWORKS. So this is the 6th video in the whole series, and it's the 3rd video, so part 3 of our FTC Drivetrain mini-series. So I hope you guys enjoyed it and you benefited from it a lot. Hopefully this can give you an example of how to use FTC drivetrains and how to use, how to build in CAD or in SOLIDWORKS within an FTC context. Because at least when I was trying to teach myself and I was learning, there was a lot of different videos out there, not a lot that was specific for FTC teams. So there are a few playlists out there, but hopefully this playlist can hopefully provide a very solid set of videos that you can refer back to. If you forget how to make things, if you forget how to draw objects, there are videos, they're all there. But apart from that, thank you guys for watching. If you enjoyed it, please share it around, and I'll see you guys in the next video.